Hi, folks. Welcome to the third video in our 8.1 lecture series. And in this video, we're going to take a look at applications of right triangle trigonometry. So in this video, we'll take a look at 4 word problems, how to set them up, how to draw the pictures, and how to choose the right trig function, the correct trig function to make sure that we can solve the problem. Okay, so get out a calculator if you have one. That'll probably be super useful. Or you can use Desmos to do that. So if you have a calculator, great. And if you don't, you can go to Desmos. It's a free online graphing calculator that also does calculations, and you can use that to follow along with the actual computation. All right, let's get started. Example 6, a 20-foot ladder leans against a building so that the angle between the ground and the ladder is 65 degrees. How high does the ladder reach up the side of the building? How far is the bottom of the ladder from the wall? So I always like to start with a diagram. I find that to be the best way to approach these problems. You do not have to be a fabulous artist. You just need to get the idea of the picture down, okay? So we got a wall and we got the ground and we have a ladder. And we hope that the ground and the wall meet at 90 degrees, even though clearly from my drawing, it's not to scale, okay? But we're assuming that it's 90 degrees and the ladder is 20 feet. So I hope we can start to see that there's like a right triangle here. So maybe we'll use the letter C for this. C is 20 feet, okay? And C is like the hypotenuse that we've been talking about in all the other videos, okay? Now, let's label this as hypotenuse. Okay, now the angle between the ground and the ladder, well, that is right here. That is 65 degrees, and that is our theta, okay, or our angle that we're interested in. Now, since this is the angle, that means that the side directly across from it is our opposite side. And let's call that side y. And then that means that the side that is next to the angle, this one is our adjacent side, and let's call that one x. Okay? All right, so we've got a diagram. It's important to draw it, but it's also important to label all the different things that are on there. Okay, so like you notice, I have the adjacent, the opposite, the angles there, any measurements they've given me are part of it. Because what we're going to do right now is choose the correct trig function. And it's not just a guess. Like, we're not just going to guess, like, oh, I'm feeling like sine today, or I'm feeling like cosine today. Like, we're going to use the information here to help us guess appropriately. Okay. So let's look at the first question first. How high does the ladder reach up the side of the building? So, in other words, I want to know this or the opposite side. Well, let's think about which trig function talks about a hypotenuse and an opposite side, all right? And so since we know that sine of theta is opposite over hypotenuse, this is the function I can use to say sine of 65 equals opposite, which is y, I don't know what it is yet, divided by 20. Okay. So again, the way that we're choosing it is we're saying we have this angle and we have this hypotenuse, so that will help us find the one thing we don't know, which is the opposite. Okay. Let's now also figure out what I might do to say how far is the bottom of the ladder from the wall. So this time I'm looking for x, which is the adjacent. Now I have the hypotenuse. I want to find the adjacent. Hopefully that's us thinking, oh, cosine of theta is your adjacent over hypotenuse. Okay. In other words, we can say cosine of 65 equals x over 20. All right. So again, it's like the different pieces of information opposite and hypotenuse tell us we want sine, but like adjacent and hypotenuse tell us we want cosine. All right, now let's go ahead and solve for what we want. Okay, so I'm going to take that sine 65 equals y over 20. And I might notice that like this y is divided by 20. So to get rid of the 20, I'm going to multiply that to the other side. And so I'm going to get y equals 20 sine 65. Right now, here is where I'm going to put it into my calculator. So I know that on your homework questions, some of them are like pretty picky about how many decimal places you go to. So I would recommend that you like write it all out and then at the very end, plug in things to your calculator. Okay. You always want to make sure your calculator's in degrees if you're working in degrees. All right. I think on Desmos, it's an easy toggle. You can just find the degrees. But now you're going to type in 20 sine 65, and let's round to 3 decimal places. So I believe you get 18.126, and we want to include the units, which is feet. Okay, so that means that like the ladder is 20 feet long, and then it's actually up a height of 18, a little bit more than 18 feet high on the wall. All right, well, now let's solve the other one. Cosine 65 equals x over 20. Kind of same idea here. I have x divided by 20. So I'm going to take this 20, go ahead and multiply it to the other side, and I'll get x equals 20 cosine 65 degrees. Same thing, I don't want to like round until I get to the very end, but when I type this into my calculator, I should end up with 8.452 feet. Okay. And so let's get this question all on one page for ourselves. But the idea here is we're going to draw a diagram, we're going to choose a trig function, and then we're going to solve using algebra. Okay. Now, it is really important that you don't round until the end. Otherwise, the homework might tell you you're wrong, but you're not wrong. You just didn't round when they wanted you to round. Okay. All right, let's take a look at example number 7. So example number 7 says the angle of elevation to the top of the building is found to be 24 degrees from the ground at a distance of 6,100 feet. Find the height of the building. Okay. So let's go ahead. We're going to start with our diagram. And I know there's a lot of words in here, but honestly, practice reading the words because if you read them correctly, you can draw the diagram correctly. And if you can draw the diagram correctly, I bet you can get the right function that you need. But if your diagram is wrong, then you're not going to get the correct answer. Okay, so as you're going through the homework problems, just kind of hold yourself accountable for like, am I able to draw that diagram? All right, so we've got a building, we've got a ground. We hope that they meet at 90 degrees, even though my diagrams are consistently not 90 degrees. And we're looking up to the top of the building, and this angle of elevation is 24 degrees. So that is our theta. I'm also going to go ahead and say this is our hypotenuse here, this is our opposite, and this is our adjacent. And let's see. So at a distance of 6,100 feet, that means this bottom part along the ground is 6,100 feet. Okay, so this, we'll say X is 6,100 feet. Now, this question wants us to find the height of the building. This is the height of the building, so let's call that Y. The only reason I'm calling it Y is because it's kind of like the Y-axis is going up and down, but you can use whatever letter you want. Okay, so choose our trig function. Okay, so let's do some thinking here. I have the adjacent, I want to find the opposite. So which trig function talks about opposite and adjacent? Well, that's our tangent theta equals opposite over adjacent. Okay. All right, let's fill in our numbers now. So we can solve. All right. So we have tangent of 24 degrees equals opposite, which is y, over 6,100 feet. Now, kind of like before, I have y divided by something. So to get y all by itself, I'm going to multiply that to the other side. And I'll get y equals 6,100 times tangent of 24. Give you a moment to plug that into your calculator, but we should get 2,715.895 feet. Okay, so that means that this building is almost 3,000 feet tall. So even though this question was different than the last one, we can kind of see that it has the same flow. We've got a diagram, we're going to choose our trig function, and then we're going to solve. And I think we'll find that the last two are going to be pretty similar, okay? So let's take a look at question 8. I'm already going to get started with a diagram. All right, so a 5-foot ladder leans against the wall. Ooh, we got another ladder, so we'll get our ground and our wall. We're a little bit better this time, but we've got our ladder. And we know that the ladder is 5 feet tall. And we can also say that side is the hypotenuse. And the base of the ladder is 2 feet away from the wall. So like this part here is 2 feet. This question is asking what is the angle between the ladder and the wall? So the ladder and the wall. That's going to be right here. Okay. So it's not always going to be the bottom angle. We kind of have to read it carefully and see what we're looking at. Now, that means if the angle is here, that 2 is not the adjacent, but 2 is the opposite because it's directly across from the angle. Okay. Okay, let's choose our trig function. So I have an opposite and I have a hypotenuse. So that suggests to me that we need sine of theta equals opposite over hypotenuse. And then we'll plug in our values and solve. So sine of theta, because I don't know what the angle is, I'm going to leave it as theta, equals opposite, which is 2, over hypotenuse, which is 5. Okay. Now, it's okay for this to look kind of weird because this is the first example where we don't actually have an angle, we just have the side lengths, okay? Now, here's what we're going to do. To get rid of this sine, that would be great, right? Like if we could get rid of the sine, then we could get the angle that we wanted, our theta. So here's how we get rid of the sine. Theta equals sine with a little minus 1 of 2 over 5, okay? Now this sine with a little minus 1 is called inverse sine, okay? So some people say inverse sine, or other people say arc sine, but both of those mean the same thing, okay? They mean that when I type sine with a little minus 1 of a number, the answer I get out is an angle measure, okay? So you're going to go on your calculator and you're going to see if you can find that sine with a minus 1 button, right? And when you get there, you're going to type that in, sine with a minus 1, and your 2 over 5. And out should come the following angle, 23.578 degrees. okay? If you're getting a weirder decimal like 0.41 something, that means you're not in degrees, but you're accidentally in radians, okay? So make sure that you're in degrees, but it is the inverse sign button that tells you how to get the angle measure you want, okay? So a little bit different in flavor than example 7, but we still do like draw a diagram, choose the function, and then solve. It's just that the way we solve for what we want is a little bit different in 8. All right, let's take a look at one last example here. Okay, so you are standing 1,000 feet away from a wind turbine that is 280 feet tall. So let's get our diagram going. We've got our wind turbine, the ground. You were standing 1,000 feet away, and the wind turbine is 280 feet tall. And the angle of elevation is going to be this angle right here. Okay, so the angle that you're looking up at the top of this wind turbine. So now that we've got an angle, I know that this is the hypotenuse, but that makes the 280 the opposite side, and it makes the 1,000 the adjacent side, okay? So we can kind of see why it's so important that we know how to label the different sides, because that helps us choose which trig function we want to use. So I notice I have opposite and adjacent, and I don't know anything about the hypotenuse, so probably the best one to use would be tangent, since that does opposite over adjacent and doesn't need anything about hypotenuse. All right, let's go ahead and plug in our information and solve. So we've got tangent theta equals 280 over 1,000, okay? Now, let's kind of get all 3 questions on one page for a moment. Is this one more like question 7 or more like question 8? And I hope that we're saying it is more like question 8 because I have the angle as the thing that I want to find, okay? So just like we did in number 8, where we wanted to get rid of sine, so we used inverse sine or arc sine. If we want to get rid of tangent, we're going to use the inverse tangent or arctan. Okay. Once we get this, we're going to find that button on our calculator. We're going to type all of this in, and we should end up with 15.642 degrees. Okay, that means that as you're standing in front of this wind turbine, you're looking up at about 15 degrees, and that's where you see the top of that wind turbine. Okay, so use inverse sine, inverse cosine, or inverse tangent to find angles. Right, that's probably a really important message for us. Those ones that look like 8 and 9, if we want to find an angle, we got to use that inverse or arc sine, cosine, or tangent. Okay. All right. Well, let me know if you have any questions, and I'll be back later on for 8.2.